Me?
Yeah.
But she can't get on the train. I know. What are you talking about?
It's got a ruler there on the paper. Then it shows a bunch of dots out here that these cut right here. And it gives the mass of an object. It says what's the net force on that object. What do you do with those dots?
Count them, divide them by 6.
Count every 6.
Well, no, we're not doing every sixth one this time. It tells you what the spacing is between time spacing.
That's the acceleration.
That's how you find the acceleration. So you find the acceleration from the dots. That was your lab. You need to know how to do that lab. Spacing isn't tenths of a second things anymore, but you need to understand what's happening there. How do you find the acceleration from the spacing of the dots? Then how do you get F net from that?
Mass times acceleration.
Just a minute. You're given the mass of the object, so you have to find the acceleration from the dot. Then there's a 10-point problem
Another, yeah.
that has 10 free bodies.
What?
So how much is each free body diagram worth?
1.
1.
Ah.
So there's 10 of them. What are the forces you put on free body diagrams? What are the only 4 we're dealing with?
Gravity, tension,
Friction, normal,
That's it. There should never be anything other than those 4 arrows on any diagram. No velocity, no acceleration, no F net, no anything except those. When do you have a normal force?
When there's a surface.
What is
It has to be a surface. No surface, no normal force. When do you have a tension?
hanging.
Be a rope. No rope, no tension.
It does.
When do you have friction?
When there's not a frictionless surface.
So this has to have a surface, and what's the direction of friction in comparison to the surface?
Opposite to the
Yes,
tension.
the opposite of
So
the
it's always parallel to the surface, right?
Yeah.
Normal force, perpendicular to the surface. Does it ever go into the surface? If this is the surface and here's the box, this would be perpendicular to the surface, right? But it always goes away from the surface. So it has to go up. So it's always away from the surface,
I
perpendicular.
learned way better about writing.
When do you have gravity? Always. If you do a free body diagram on this thing that doesn't have gravity there, you will miss it.
Are we going to have anything that's not a flat level surface?
Yes. On these free body diagrams.
So it's going to be at an angle?
Okay.
Okay.
Let me see.
But we're not going to have to solve for anything. Just, that's easy.
Alright. There's one exception to this rule. And I'm going to tell you what the one exception problem is on this thing. You got a rock falling through the air at a constant terminal velocity. What is the free body diagram for this?
Way
You'll have
down.
gravity down, right?
That's it.
But if it's going at a terminal velocity, that means the sum of the forces is 0. You have to have another force going up.
Oh.
This is the only case where we're going to put that upward force as friction. It is a friction force of sorts.